This is a 4-year staged implementation project where we've been kind of increasing in terms of the number of volunteer TxDOT districts that are willing to try this out. So this year we're up to 7. And every year that we continue to track, we characterize the binders that are used by the new spec, even though the new spec is now just now being implemented sort of this year in some districts, not statewide. And then we characterize the binder according to the new spec, and then we monitor the performance over the critical first year.
TxDOT's been sponsoring research at TTI for about 15 years. Several research projects building on each other to the point we're at now, where we have an implementation project to help us get the specification that was developed in the research into practice.
This project was about taking the seal coat binder specification, not the two materials put together, but the seal coat binder specification, kind of moving it into the next century. So we're using a lot of the same equipment, and but with different parameters because of different distresses, different aging states, and tying performance-related properties directly to the climate that they're going to be used in. So the hope is that there'll be less variability in grades, it'll encourage more competition, and it'll be more to the performance of seal coats and try to preclude the major distresses, which are aggregate loss and bleeding.
This specification is performance-based and climate-driven, so we can select a binder to perform in the climate in which it does perform. The Panhandle gets cold, but it doesn't quite get as hot as it does in South Texas. We can tailor the specification, tailor the materials to resist the loss of rock at high temperature and low temperature for those temperature regimes.
It is tying it directly to the broad climate conditions that we have here in Texas, where the current specifications do test at some temperatures, but very set temperatures, not at different temperatures that would be at different locations across the state. And right now the current specifications also don't capture the low temperature end, and that's critical for aggregate loss, which is probably the primary form of distress of seal coats. TxDOT puts down an enormous amount of mileage every year in seal coats and spends quite a bit of money, millions of dollars.
The chip seal generally lasts between 7 to 10 years, and if we can get only one additional year out of only 20% of the projects we do every year, we can save about $9 million a year. So, those are small goals that can produce big results.